everything. We're good to go. Boop, 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 boop. Happy Bowtie Friday. Okay, so I just want to show off Scaffold-ETH, quick little 20-minute demo, just how to get started building on Ethereum and with Solidity and in any EVM compatible environment. So everything starts with Speedrun Ethereum. You can go to Speedrun Ethereum to get started, and that will help you set up your profile and get ready to go over here. And it kind of takes you through just like the early concepts of learning, kind of just like early concepts of Solidity. So if you haven't dove into Solidity, a really great way to do it is to start with Scaffold-ETH and go to Solidity by example. Let's see, Solidity by example, there it is. And you can really just like go through and kind of like find these things, like a mapping, right? Go learn what a mapping is. Go learn what a modifier is. And if you're a decent developer, you should be able to pick up the syntax of Solidity really quickly. So go through this early speed run of pulling down Scaffold-ETH and learning these early concepts. Now, this is like MEV and DeFi, so I think the concepts that other folks are going to talk about are going to be far more advanced, but I still want to make sure you have a good starting point and you know how to tinker with Solidity. And what I mean by that is you fire up Scaffold-ETH and you've got your smart contract over here and you've got your front end over here. And this is going to let you kind of make small changes. Like if I just make a small change to my app or to my smart contract and I go ahead and yarn deploy that, we're going to see these changes reflected in the front end. We're going to see a new contract get deployed and some extra exclamation points for some reason. So this is the heart of Scaffold-ETH. This kind of just like Remix, where you're kind of like making changes and you're getting like an interface. The same thing where you're going to make small changes in Solidity. You're going to test test your assumptions and then make quick deployments over here where you can interact with it. Okay, so let's talk about this interaction over here on the right. You've got your smart contract and you can make calls on it. But let's zoom out just a second and look at this wallet up in the top right. If you go to Scaffold-ETH using an incognito window, you're going to see we've got like pink guy over here, right? So you get a burner wallet on page load. As you land on any Scaffold-ETH app, it's going to generate you a burner wallet, which means private key and local storage. It's going to take that and kind of keep it for you so you can make quick and fast transactions. Watch this. We'll grab some funds from the faucet. We'll go to our contract and we'll say hello world and we'll hit send, right? And there we go. So we're interacting with our contract. That was a transaction right there. And you'll notice there's not a bunch of like pop-ups and dialogues. That's because we're using burner wallets and we're signing these transactions quick and fast. So it allows you to just tinker with your smart contract and kind of just poke at it and make sure it does what it needs to do without a bunch of annoying pop-ups. Okay, so let's move on. Let's write just like a little bit of Solidity just to get started, and then I'll kind of kick you off to kind of the next step. So I don't know. Let's one of the first things that it talks about is global units and primitives and data types, right? I know this is probably like a lower level thing for like we're talking MEV and DeFi, and this is kind of starter stuff, but I want to just make sure you got that starting point. So let's just look at some global units. If you look at globals in Solidity, we're going to find things like message.sender and message.value and block.timestamp. So message.sender is the one that you're going to use a lot, but let's use a different one here. Maybe block.timestamp, right? Like the time it gets started. So let's do like UN256 public start time or something like that. And we'll just set the start time to block.timestamp, right? I don't know. I'm just tinkering around here, kind of messing around. And then let's say, let's require that you, let's see, the block.timestamp has to be greater than the last time plus 10 or something like that, right? So that means you can only make a transaction every 10 seconds for some reason. But if maybe you were setting up a Web3 cron job, you might want it to run once every 24 hours, right? And so you could set that to 24 hours, right? This is another, what is it? We can see right here, 24 hours, right? We can actually just type that right into Solidity like that. That's pretty cool. But let's just go with 10 seconds just to prove that it works. And then let's have some error that says like not yet, right? Okay, and let's test one other thing. Let's bring in the our front end user, green guy over here. And let's have an address public, and we'll call it, we could call it owner, but we called it boss the other day, and I like that in a demo, like just to show that like owner isn't some like arbitrary thing. This is just a variable we're tracking. You're writing a smart contract. It's like a little app that anyone can run. It's going to live on all these nodes, thousands of nodes across the network. Here we go. We've got the boss, and we're going to say require that the message, oh man, if I could spell require that the message.sender, the person who's getting into call this function that could be a smart contract too, has to be equal to the boss, right? And if you're not the boss, we're going to say not the boss. Okay, so we've written this, we've changed our smart contract a little bit. There's this purpose variable that's kind of like the greeter contract, and then there's this function called set purpose that lets you set the purpose, update that. But then we've added some new rules here. We're tracking a boss, and we're tracking a start time, and we're making sure that only the boss can edit it, and only every 10 seconds for some reason. Just really showing off how to tinker with this stuff. You kind of make small changes, then you yarn deploy, then you come back over here and you tinker around with it. So, okay, so the first thing is just like timing, right? I should be able to say hello world, not yet, right? It's gonna be 10 seconds after the deployment. So we gotta wait a second here. There it goes. Okay, so at least we know our timing's not working, right? And if I try to set it again, what? We did something wrong. Oh, we've got to update the start time, right? And this is how you find out. Like instead of writing a whole, extensive test base, I'm just tinkering around here and kind of learning about Solidity and figuring out how this works. I forgot to update the start time to block.timestamp. Duh, jabroni. All right, here we go. Let's try that. Okay, now the other thing we want to test is this line where it says message.sender has to be equal to boss. So only the boss can get in here and set the purpose. Let's go ahead and open up an incognito window and go to localhost again. Let's see who we get here. Okay, cool. Kind of like we got green and red and we got green and blue over here. So let's grab some funds for green and red. And if they say hello world, even if we're after our 10-second time, this is going to fail because it's going to say, oh, not the boss, right? So we're able to test these require statements, test these settings, test out our assumptions, make sure this works how we think it does, just as we're like building our app, right? And then of course we'll want to write an extensive test bench that really tests that this all works in all sorts of different kind of edge cases. But right now we're just kind of like tinkering. We're quickly tinkering around with this. Okay, this is cool that like only the boss can set it. Let's see, make sure hello world, only the boss can set it. And if they say, hey, again, it's going to say not yet, right? Very, very cool, but it's kind of like a centralized attestation machine. Only this person can set it, right? So what if we wanted to change this a little bit? Maybe make this function payable, and then we'll do something like, let's require that the message.value is greater than or equal to 0.001. Heck, let's make a price variable. So let's say uint256 public price is going to be set to 0.001 ether. All right, so you got to pay a little ETH to set the purpose for some reason, right? And we put that there and we say not enough, right? Okay, let's go test it out. And actually, like, I don't know, I decay if I want this timing in here anymore, right? I kind of figured out how timing works, kind of does this thing, but I don't know if I want it in this version. I'm just testing my assumptions, trying things out. There we go. Compiles, deploys. Now, if I want to say hello world, I'm going to have to send in this amount of way. Or you could say 0.001 ether and hit this little green button. Obviously, when you're building your app and you're shipping this thing for customers, you won't have them have to convert it to way, but this is a developer's tool to get a front end built. And this is kind of just like a stand-up kind of straw man front end that you'll use to kind of test things, but then kick it away and build something more advanced once you get going. But let's try that real quick. We'll do 0.001, take it times 10 to the 18, and boom, we set our purpose to hello world. And now the contract has $1 in it, right? And if I say, hey, and I spend less, let's take off a couple zeros there, it should say, hey, not enough, right? So we're testing these require statements. We're testing these rules. We're writing rules. We're trying them out. We're kind of testing our assumptions with Solidity, and we're kind of learning as we go, grab things from Solidity by example, go through all of these different concepts. Like if I go to mappings, let's just grab a mapping real quick, right? Throw a mapping in there. What do we got? We've got some mapping to an address to a uint. That feels a lot like balances, right? But maybe we have these balances here, and then on constructor, we set the balance of the boss to something, right? I don't know if that needs to be up there or not. Let's set the balance of the boss equal to 100 way, right? So then let's deploy it and let's go tinker with it. Instead of like kind of writing your contract and then writing tests that make sure this is all set, you can just get in here and tinker with it. You can poke right at your contract. So let's see, what is the balance of the boss after it deployed? Hey, it's 100. Cool. Well, what can we do with that? Let's make a transfer function, right? And let's have some address to and some uint 256 amount, and we'll set that to public. And what do we do in our transfer statement? It's actually pretty easy, right? Like the balance of the message.sender goes down by the amount, and the balance of the to address goes up by the amount. And thanks to Solidity 8 and greater, we've got safe math built in. So if anything rolls over here, if we get any kind of overflow, boop, 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 there we go. If we get any kind of overflow, it'll revert. So that's it. That's a transfer function. We basically built like a little digital currency right there, right? A little decentralized currency. Let's see. Let's check it out. So new contract is deployed. I can check my balance. It's 100, but now I want to transfer, right? All right, let's bring up an incognito window. Bring that homie up over here. So we got purple guy over here, and we got green guy. Green guy has 100. Purple guy has 0. Let's send some to purple guy. So we copy their address. Notice this in Scaffold-ETH, you kind of have the addresses have blockies next to them. If I click this, it takes me to the block explorer. As I switch it from network to network, it'll follow that block explorer. If I paste this in over here, oh, not there. If I paste this in over here, I get a nice blocky preview. All right, let's send that dude 10. Ship it. Awesome, it went. So now if I check this dude's balance, it's at 90. And if I check this dude's balance, it's at 10. Cool, we got a digital currency, right? You can start messing around with how this works. So pull that out. I don't want that. I don't care. We got the boss. I don't want a digital currency right now. I was just tinkering with how mappings work. What I do want to show is something really fun, a simple one-liner here that can make this interesting. So I know I'm kind of speed running this. I only have 20 minutes, so I'm compressing a lot into one thing. But what we have is we have this set purpose function, and we have them paying a price to set the purpose. But the price basically stays constant. And I kind of want that to go up on a price curve. So building a price curve kind of sounds scary and kind of heady, and like it sounds like there's calculus involved. But since these are discrete one-off hits, you can just basically say, after someone pays the price, we can say price equals price times 101, and then divide that by 100. Remember, no decimals. The only time you can have those decimals is when you follow them with like ether, where it's multiplying by 10 to the 18. So this kind of just really kind of shows a few little gotchas with Ethereum all rolled into one, but also how it's very powerful. Let's save that and deploy it and see if we've built an attestation machine with a price curve for some reason. All right, awesome. And then if I set the purpose to hello world, and I pay this original price, watch what happens to the price. Now the price is at 101. And if I try to pay the original price, it's going to say something like not enough. So if I pay that price, look at how this price is going up on a curve. Whoa, this is getting expensive. Something like that. I can't spell expensive. It doesn't matter. Ship it. Awesome. Okay, we got 4 minutes left. What can I show you on just basically the 0 to 1 here? Deploying. Let's say you like this. You love it. It's great. It's ready to go. You've built a nice little example UI. You're ready to ship this thing. What you'll do is you'll yarn generate an account. That's going to create a local mnemonic. Then you'll fund this account probably with some MetaMask or some money somewhere. Let's see. Can I use... Oh man, I don't want to. Okay, Rinkeby. We've got this dude on Rinkeby. We're going with it. So let's send this dude some Rinkeby and let's deploy this contract. Point 1. Send. Waiting, go. Okay, so this will deploy our contract. Basically, we've funded our generator, our deployer account, and if we do a yarn deploy -- network equals Rinkeby, as soon as this transaction goes through, we should be able to ship. I'm just going to start sending it and see what happens. I'm going to say something like not enough funds. There we go. We're shipping it live. So this doesn't have to be Rinkeby, right? It could be any public network. I could say yarn deploy -- network mainnet and ship it. So there it goes. So now we have to make one other change. Over here in our front end, we have to tell our app that we're running on Rinkeby. And as soon as I make this one change to the app, this entire app is going to adjust and it's going to run on Rinkeby now. And every time you click any address, anytime you click through any of this stuff, it's going to take you to the Rinkeby block explorer and it's going to know. So there is our app. Here's our app. I could say, hello world. Oh, let's connect our MetaMask, right? Now that we're on a public network, it makes a lot of sense to have our MetaMask connected in. A lot of other wallet options there. Scaffold-ETH has all that stuff out of the box. But let's try hello world again, and let's pay a little Rinkeby, and let's ship it. And there we go. We get a MetaMask confirmation, and we can send it. So there we go. We wrote a smart contract. We deployed it. Then we have our app here. And the last thing we would do is we would do a yarn build, and that would build our static app. And then we could do something like yarn IPFS or yarn S3 or yarn surge, and we could put that up behind a URL and share that URL with our friends, and they could use our app. That's basically everything I have. I think I'm at time. I want to reiterate, speedrun Ethereum. You get in here, grab Scaffold-ETH, watch this video, run through the basic concepts, and then get started. You'll build a simple NFT. You'll build a decentralized staking app. You'll build a token vendor, a dice game. You'll build your own DEX. You'll build your own multisig, your own SVG NFT. There's just a lot of things to cover. You think you know, but you don't until you test yourself. So go take on those challenges, try them out. Thank you, thank you, thank you. Happy Bowtie Friday. I'm excited to learn more MEV and DeFi stuff. Hit me up if you have any questions. Let's drop Speedrun Ethereum right into the chat. Boom, there it is. Oh, also, I'm Austin Griffith on Twitter. So if you need me, find me at Austin Griffith. Let me throw my profile up there. Boom, hit me up, hit me up. Thanks for having me. Hopefully I left a little space there since I got started late. Let me know, are we good? How we doing?
You're doing great. Exactly on time. Thanks so much, Austin.
Perfect.
This is great. All right, we're going to transition to the next session now. All right, and we're going live in 5, 4, 3, 2, 1. And I can intro you. Hey everyone, we're up for our next session. We have Regan from Open, and she'll be doing a talk on Squeak with me. And I'll let you take it from here.
Thank you so much. Hi everyone, my name's Regan, and I'm super excited to be